Welcome back, Physical Science 20. This is the first lab in the HT2 booklet, and it's looking at heats of solution and reaction. So if we just look at a couple of things and highlight a few things. Two types of processes commonly involve energy changes, so we're either looking at chemical reactions themselves, reactants being rearranged to make products, or dissolving something often can involve the release or absorption of heat. So we'd be looking at a few of each, so some involving a chemical reaction and some just simply involving dissolving. Heat of reaction is the overall energy absorbed or released during a chemical reaction, and heat of solution is the overall energy absorbed or released during the solution process, so when something gets dissolved. Both are the difference between the energy absorbed to break bonds and the energy released when bonds are formed. So in order to break bonds, energy has to be absorbed, and when new bonds are formed, energy is actually released. So whatever one is larger there will determine whether a reaction is endothermic or exothermic. So in this activity, you'll investigate two examples of heat of solution and one example of heat of reaction. First example of heat of solution is the heat transferred when concentrated sulfuric acid is added to water. The second is the dissolving of an ionic compound, ammonium chloride, in water. We're going to use ammonium nitrate though, since I don't have any ammonium chloride. It's very similar. So when we dissolve ammonium chloride, it breaks off into ammonium ions and nitrate ions. If we're looking at dissolving sulfuric acid, it breaks up into H pluses and SO4 2 minuses. When an ionic compound dissolves in water, energy is needed to break the bonds of the crystal. As the ions attach to water molecules and become hydrated, energy is released. The process of is endothermic if the energy needed to break the bonds is greater than the energy released when the ions attach to water. So if that initial energy is more, it's endothermic. It's going to absorb more energy than release. And conversely, it's exothermic if the energy needed to break the bonds is less than the energy released when the ions attach to water molecules. An example of a chemical reaction with the measurable energy change is the reaction of an acid and a base. In this activity, you will determine whether the reaction of a hydrochloric acid with sodium hydroxide absorbs or releases or liberates heat. Liberate means to set free, so release. So the only material change we're going to make is instead of ammonium chloride, we're going to use ammonium nitrate, NH4NO3. Problem: how do you measure temperature changes during chemical reactions and solution processes? So, and the objective here, the temperature change of different processes, we're going to measure them, and then difference between exothermic and endothermic. So to determine if what we have, if it's an endothermic reaction, let's assume we have our little reaction in the bottom of a styrofoam cup, and if we have our thermometer nearby, and if the temperature goes down, that means that reaction is absorbing energy from its surroundings. That thermometer happens to be in the surroundings. So if it's absorbing, it's going to be endothermic. And yes, if you're to put your hand there, it would also absorb energy from your hand, and you would perceive that as cold. Exothermic reaction: if our reaction releases energy to the thermometer, which is nearby, temperature goes up, or you could say it feels warm, energy is being released, so that is exothermic. So you may want to copy that down just so you have the difference. Safety precautions, we'll go over that as we get into there. You for sure have to wear goggles because we are working with acids and bases. Likely gloves would be good to use as well, which I will have. Pre-lab, so define what heat of reaction is. 2, distinguish between exothermic and endothermic processes. Read the entire laboratory activity, form a hypothesis about how to distinguish between exothermic and endothermic processes, and record your hypothesis right here. So I kind of talked about that on the first page of this handout, so it should be fairly easy and straightforward. Omit number 4 and number 5, describe the anticipated temperature change of a system in which the exothermic process is taking place. So again, if you look at those pictures on the bottom of the previous page, you should be able to get that. So procedure, the first one, sulfuric acid. Measure 45 mils of water poured into a foam cup. So we've used these before. Have the foam cup in a beaker too, just so it doesn't tip. So we'll use distilled water. If you look, you'll see it in the room there. Use a grad cylinder, a 100 mil grad cylinder to measure out the 45 mils. Insert the thermometer into the water. After 2 minutes, read the temperature of the water. Shouldn't change too much because the distilled water is sitting at room temperature already. And next, 3, use a grad cylinder to measure out 8 mils of sulfuric acid. Carefully pour the sulfuric acid. Now, when you're measuring it out, it's in a bottle. I'll have some poured into a beaker. And of course, pouring from beaker to cylinder is much easier than pouring from bottle to cylinder. So just be aware of that. It's clearly marked. Carefully pour it into the water without splashing. Stir it with the stir rod. Have the thermometer in there standing still to measure the highest temperature attained. Then dispose of the acid as directed by me. I will have a beaker referred to as beaker or acid dump at the front of the room. It's a big beaker. Make sure you pour it into there, and then rinse out the cup. Part B, heated solution of ammonium chloride. In our case, we're using ammonium nitrate. This you should be able to just dump down the sink after. Measure 30 mils of water. Pour the water in the cup. Insert again. Look at the temperature after 2 minutes. Measure 5 grams approximately of ammonium nitrate crystals on a piece of weighing paper. Carefully pour the ammonium nitrate into the weighing paper, into the foam cup, and then again stir it and note the temperature. Here we're referring to the lowest temperature reached, and basically when the temperature stops changing. And again, that can just be flushed down the sink with plenty of water, and then of course rinse the cup. Heat of reaction. Use a graduated cylinder to measure 20 mils of 1 molar acid. Pour it into the foam cup. Again, thermometer after 2 minutes. Use a grad cylinder to measure 10 mils of sodium hydroxide. Pour that in the cup and stir and look at the thermometer. Measure and record the new temperature attained. Try to look at when it stops moving. That's a hint. And then that you can dump it in the acid beaker as well, even though it should technically be neutral. Okay, so your hypothesis goes there. You'll put those initial and final temperatures on here, and it's kind of set up backwards. They have the initial temperature of water after adding the H2SO4. So technically this is the after, this is the before. So it should be after minus before, so it's kind of set up backwards. So make sure you don't fall in the trap of taking initial subtract final. I want final subtract initial. And by looking at your numbers there, specifically whether it's positive or negative, that should give you a hint as to whether it's endo or exo. All right. And that's it. That's fairly straightforward. Questions I want you to do are on the back here. So calculate and record the data table of the temperature change. What observations allowed you to compare the heat flow in the 3 reactions? So what is it that you actually measured in the lab? That'll give you a hint. What is the experimental evidence that indicates whether a reaction is exothermic or endothermic? 4, would the temperature change in part A be different if the same amount of water but less acid had been used? Explain. In part B, energy is needed to break the ionic bonds of the crystal. As ions attach to water molecules and become hydride, energy is released. Explain how you might conclude that more energy is used to break the bonds than being released. So we talked about that earlier. Whatever you got in the your data here should help you indicate what happened there, and you should be able to come up with a reason. Error analysis. To test your hypothesis and activity, was important that the amount of reactants and the temperatures be measured with accuracy and precision. Explain. So did we have to be exact in all of our measurements? Tell me. And asked, of course, what we're going to do with the numbers afterwards. And yes, I'd like you to do the real chemistry. So number 1, explain how a cold pack, often used in emergency or sports medicine, works. So you have to look that up online likely. Combustion of fuels is an exothermic process. Explain how the heat energy from this type of reaction is often used to do useful work. So combustion of fuels, where do we use that? Why do we combust things? And then 3, would it be explain why it would not be practical to air condition a home or business by using an endothermic chemical reaction like we did earlier here. Okay, so again, we're talking about heating up your whole house. All right, so that is HTD2, and that's the first lab. heats of solution reaction. See you again.